Working backwards from a reciprocal function can be a little bit more challenging. Here we're going to start with a linear function that we have taken the reciprocal of, and I know that because of the format of the denominator that they give us, ax plus b, also known as mx plus b, which is our slope-intercept form. So sketch the graph of the original function. So that's step one. So I'm going to do that in black, right on my grid. Okay, so first of all, asymptotes always occur at intercepts. So I know I've got a point right at x equals 2. Okay, so again, asymptote is going to happen at my x-intercept. I also know that my invariant points are when y equals 1. And it can be positive or negative 1. So I've got those points right there as well to kind of help guide me along. Finally, I do actually have a given point, and my y value here, this is my 1 over f of x. So my original output should be the reciprocal of that, so it should be 3. So I'm going to have a point at positive, oops, there at 3 and 3. And because of symmetry, we can also guesstimate that we have one there, but really all we need is these 2 points in order to be able to draw our straight line. And that's my original function. Once we have the original function, writing our equation shouldn't be too terrible. We can figure out our slope by going rise over run. So rise is 3, run is 1, so slope is 3. I've extended my graph far enough that I can actually see where my y-intercept is, -6. So that's my b value. Therefore, I can fill in my linear equation as 3x minus 6. There we go. Okay, so invariant points, asymptotes, and just other given points are going to be your bread and butter for this. So for both of these, we're going to do the same idea. 2a, I can identify there's only one asymptote, so that means that I only have one x-intercept. Now I'm going to use red this time, just because my picture's in black. So I can identify where my x-intercept is based on my asymptote. I can also kind of guesstimate that I've got points here and here. So at negative, that looks like -1.5 and -3.5. I get those guys there. So in general, I can sketch out what my parabola might look like. And there we go. So this time I'm not given a specific point, so I just have to go with my invariant points. And again, that's when y is equal to positive and negative 1. Okay. Here we're not actually asked to generate the equation, so that's also a bonus. We aren't given any points, so that would kind of be impossible. We just guesstimated where those are. B, I have 2 asymptotes, so I'm going to have 2 x-intercepts. And what we can do is from here, we can figure out where our vertex is because we actually are given a point. So my minimum of my middle section is where the reciprocal of my vertex. I'm going to take this and I'm going to go, okay, well, if that's 1 over f of x, then f of x should be 2. So my vertex is at 0 and 2. And it's opening downward because all of these pieces outside of my asymptotes are negative. And I can already kind of see that because if I've got my vertex here, my x-intercepts are here, it has to be going downwards. And so from there, again, I know where my invariant points are, so that can help too. And there we are, f of x in both cases. Okay, so that's how we tackle those kinds of questions. Although this lesson does continue into kind of another piece of it, please stop now and do some practicing of just graphing quadratic functions and their reciprocals, because that can be a little bit confusing. Make sure you go back and you are constantly referencing, why does it have 1 asymptote? Why does it have 2? Why does it have 0? And be able to make those connections really quickly, because that just makes your life a lot easier when you go ahead and try and start to graph them, and conversely when we're working backwards.